Hi students, today we are starting quadra- coordinate geometry, the fifth lesson of geometry of SSC. What is coordinate geometry? You know the graph system, first quadrant, second quadrant, third quadrant, fourth quadrant. If you want to measure this linear distance of AB, then you will use scale, your simple scale. But if we give 2 points in any quadrant, and we say if you asked to find the distance between these 2 points, then scale is not useful. Scale is not useful. This is a graphical distance. So you remember these things: first quadrant, second quadrant, third quadrant, fourth quadrant in graph. So any 2 point they can give in any quadrant, correct? So to find a quadratic distance, there is a formula. There is a formula. You know, each point has corresponds to two coordinates. Coordinates. The first one is x coordinate. The second one is y coordinate. Correct? So in this way, each point carry two coordinates. And if they give you 2 points, suppose A and B corresponds to again x and y. So it will create problem, confusion. So we are changing the names to x1, y1 for point A and x2, y2 to point B. So by using these 2 points, how to find the distance between these two? Not simple distance, it is graphical distance. It is graphical distance. How to find? We will see the formula. So what is the formula then? These two are the points with coordinates x1, y1 and x2, y2. So distance AB, A comma B is equal to under the root x2 minus x1 the whole square is equal to minus, I think plus, added, plus y2 minus y1 the whole square. This is x, a minus b the whole square. This is also a minus b the whole square. Then you have to expand and find the values, or simply you will get the numbers. You don't have to expand. Very easy. It will be plus or minus. Answers will be positive. The final answer must be positive. So this can also be written as x1 minus x2 the whole square plus y1 minus y2 the whole square. Both are correct. Both are correct. So using this formula, we are going to solve exercise number 5.1. What it is, let us see. Exercise number 5.1. Question number 1. Find the distance between each of the following pairs of points. So first one is A, 2, 3. A corresponds to 2 and 3. And B corresponds to 4 and 1. 4 and 1. Both are positive. So let assumptions, let x1 is equal to 2 and y1 is equal to 3. x2 is equal to naturally 4 and y2 is equal to 1. After this assumption, first point's coordinates are x1, y1 and second point's coordinates are x2, y2. By, you have to write by distance formula, distance A comma B is equal to under the root x2 minus x1 the whole square plus y2 minus y1 the whole square is equal to. Put the values now. What is x2? It is 4. What is x1? It is 1. The whole square plus what is y2? It is 1 minus what is y1? 3. The whole square, which is equal to under root 4 minus 1, 3. 3 the whole square plus minus 2 the whole square. Squares are always positive. Squares are always positive. So it will be 9 plus 4, which is equal to root 13. You can check answer in your sorry. It is 2. So it is 2 square. It is 4. So it is 8. So it will be under root 4 into 2 is equal to 2 root 2 is the distance. There will be no units. There will be no units to these distances. As distance is graphical distance, you don't have to give any units. Sorry for the using wrong. It is 2. Yeah, thank you. This is, it happens. So this is the way we related with x1, y1, we related with x2, y2, and lastly the distance. It's very simple. You try for them. I will give you one more example. If your calculation part is strong, you can get correct marks in this examples. So second one, P is minus 5, 7. P corresponds to minus 5, 7 and Q corresponds to minus 1, 3. Minus 5, 7 and minus 1, 3. Okay, very nice. So suppose let x1 is equal to minus 5 x2 is equal to y1 is equal to 7, x2 is equal to minus 1 and y2 is equal to 3. Correct? Now, by every time you have to write by distance formula, what is that? Distance PQ, P comma Q is equal to under root x2 minus x1 the whole square plus y2 minus y1 the whole square. So it will be, after putting the values, what is x2? Minus 1. See, and what is x1? Minus 5 plus, see, don't, every time I am telling you, don't forget the signs. So x2 is minus 1, minus of the formula and minus 5 of the coordinate, plus you can put square bracket also. In another bracket, what is y2? It is 3. What is y1? It is 7. So it will be 3 minus 7 the whole square. This one minus 1 in the bracket, minus 1 plus 5 the whole square plus minus 4 the whole square. Are you getting it? Huh. So this will be minus 1 plus 5, it is 4 the whole square plus minus 4 the whole square. Squares are always positive. Again I am repeating. So it will be under root 16 plus 16. Next step will be is equal to under root 32. So we cannot keep complex number in the root sign. So it will be 16 into 2. This is perfect square. So 4 will come out and 2 will remain inside. So distance, finally, distance P comma Q is equal to 4 root 2. This is your final answer. Understood? So try for other calculations. Your answers must be perfectly right at the first time only. Try for these distances. You will get success by practicing. Right? We are moving for next question. So next is 3. Question 3, that is R corresponds to 0 minus 3 and S corresponds to 0 5 upon 2. 0 5 upon 2. So this is fraction. You don't have to get scared by fractions and all these things. You are in 10th standard now. So suppose we are assuming, let x1 is equal to 0 and y1 is equal to minus 3. y1 is equal to minus 3. So automatically x2 will be 0 and y2 is equal to 5 upon 2. So again, by distance formula, distance r comma s is equal to under root x2 minus x1 the whole square plus y2 minus y1 the whole square is equal to, who is x2? 0. Under root, who is x2? 0. Therefore 0 minus 0 the whole square. They have given it. We can't do anything. 0 minus 0 the whole square. Plus, what is y2? It is 5 upon 2 minus 3 the whole square is equal to. This term does not have any meaning. So 0 plus, by cross multiplication, 5 upon 2 plus 3 upon 1, it will be, don't write this 0 again. So 1 5 is a 5 plus 2 3 is a 6 the whole square. So there will be 5 plus 6 the whole square is under root 11 the whole square. 11 the whole square. And the cross multiplication term definitely you will forget is 2. Is 2. So 11 upon 2 the whole square. Final answer, you have to take the square root. You have to take the square root of this term. And here distance is always positive, so there is no any sign of negative. So it will be 11 upon 2. Distance r comma s is equal to 11 upon 2. This much simple examples are there. If you know how to change the sign, how to square them, how to subtract or add, and taking out the square root. Taking out the square root in the final example. Next one is, in this case, fourth one, x2 is 5 x2 is 5 L, point L. Fourth one, L corresponds to 5 and minus 8. Minus 8. And Q is minus 7 minus 3. Q corresponds to minus 7 and minus 3. So again same, let x1 is equal to 5, y1 is equal to minus 8, x2 is equal to minus 7 and y2 is equal to minus 3 by distance formula. By distance formula, distance LQ, L comma Q is equal to under root x2 minus x1 the whole square plus y2 minus y1 the whole square, which is equal to, who is x2? Minus 7 minus 5 the whole square plus, who is y2? Minus 3 minus into bracket minus 8 the whole square. See, this quickness comes after practice. x2 is minus 7 minus of the formula 5. So there is no double minus sign, but in this bracket minus 3 is y2 minus of the formula and minus of the 8. Let's check. Yes, minus 8. Correct? So this will be minus 7 minus 5, it is minus 12 the whole square plus minus 3 plus 8 the whole square, which is equal to 144 plus minus 3 5 8, it is plus 5 the whole square. So it will be 144 plus 25, which is equal to 169, which is equal to 13, taking square root. Taking square root. So final answer is distance LQ, L comma Q is equal to 30. Every time we have to write these things, taking out square root by distance formula, distance LQ, and the main formula. So this much simple these examples are, provided that you must know the calculations ability and sign changing mastery. Okay. So I started sixth one. Fifth one you can do because we have done such examples. Now there is a fraction, so I started sixth one. So suppose or let x1 is equal to minus 7 upon 2, y1 is equal to 4, x2 is equal to 11, and y2 is equal to 4. Therefore, by distance formula, distance w comma x is equal to under root x2 minus x1 the whole square plus y2 minus y1 the whole square. Quickness is important. What is x2? It is minus 7 up, sorry. It is minus 7 upon 2 minus 11 the whole square plus what is y2? It is 4 minus it is 4 the whole square. Let us check the coordinates one more time. Yeah, x2 is 11, sir. This happens always. So x2 is 11, x1 is minus 7 upon 2. So 11 minus of the formula minus of the coordinate minus 7 upon 2 the whole square. So you have to be very careful who is x1 and x2. At this age it is happening with us. So it may happen with you also. Be careful. So it will be 11 plus 7 upon 2 the whole square plus 0. 4 minus 4, 0. Then come to this side. It will be under root cross multiply 22 plus 1 upon 2 plus 0. Whether you are writing or not, it doesn't make any difference. So it will be 11 to the 22 and 7. It will be 7. So finally it will be 29 upon 2. Taking square root, it will be 29 upon 2. You can keep as it is, or you can divide it also. So final distance between w comma x is equal to 29 upon 2, or 29 upon 2 is 14.5. You can cut or you can keep as it is. Clear? This finishes question number 6th of 5.1 first question. Question number 1 of 5.1, and this is sixth question. Next question is collinearity. Yes. Determine whether the points are collinear or not. By using distance formula, you have to find two distances. There will be 2 points, 3 points will be given, A, B, C. A, B, C. 3 points will be given, A, B and C. First, you have to find distance AB. Then find distance BC. If condition is if distance AB plus distance BC is exactly equal to distance AC, you will get some values, no? Value and last value. These two values, when you add these two values, it should be value. It should be equal to value of AC. In simple, sum of two small distances should be equal to one large distance. This is very simple to remember. Whenever you get three distances, PQR, so PQ, QR, that PQ plus QR must be equal to PR. Clear? We will see these things in the next lecture, because my technical team has told me that the video should be smaller. It is easy to upload them. Okay? Yeah, thank you. We'll meet in next video of the same subject, same topic, but it will be second part of the same thing. 5.1 second part.